So chapter 4. So on chapter 4 is one of the two chapters that talk about congruency and similarities. So on chapter 4, we are going to be doing constructions. So we're going to be doing constructions or proof, basically proof using a I'm sorry. We are going to be doing construction of proofs of the different theorems. For example, of congruency of triangles. You have several in here that it's just to prove, but they're not coming. You don't have to do those constructions on the test. Okay. And I don't even put it on the homework either, because those are just activity for internalization, like activity for discovery. So for example, let's see here. So for example, page 88 and 89, that is just discovering to be able to draw different triangles, right? And then page 90, 91, that is trying to prove or discovery that when you have three given sides of a triangle, right, are congruent correspondingly to three other sides of another triangle, then the triangles are congruent. So basically, we are only proving in these activities side, 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 and angle, side, angle. So, and it goes all the way to page 94. Those are the only ones that I am not doing because I really don't have time to do it with you guys in here. But I will demonstrate the other ones that are coming on the test and you have on your homework. Okay. So those are demonstrating. Let me just skip these right here. Okay. Then the other thing, yes, and you do have it also on your homework. You do have some little proof, table of proofs. Okay. Where we are going to use all this information that we know, and I'm going to give it to you to write in a minute. All this information that we know about triangles, congruency, and triangle similarity, and the angles forms when you get to parallel lines, component, transversal, all of that information, and then what you know about polygons, especially triangles, because this section we're using all triangles, especially triangles, right? Everything that you learned in the previous chapter about triangle, isosceles triangle has two equal sides, and the two congruent angles are opposite to the congruent side. The diagonal that is perpendicular to the base of a isosceles triangle is a perpendicular bisector. So all of those little tiny informations, all of that is going to be used to be able to do these. Okay. So let me first show you some vocabulary that unless you went through the notes, you probably don't have, and you can write it in your foldable if you want to, right? So I keep asking my students to write additional things that they don't have. See, we wrote things here, a bunch of things that there were in the notes, but they were not in the foldable. See, we wrote it on the foldable. So as we move along, right? So additional information for central angle, consecutive same side, angles for supplementary, axioms, right? What are axioms of lines and points? Was this a simple curve? What is a closed curve? Because you do have something like this on the homework. Opposite angles of the largest side of a polygon is always going to be the largest angle and vice versa. So you should be able to have filled these out. So all of this is part of the foldable that you did in the previous thing. And then we started filling it out with additional information as we move along. Okay. And using the class notes. Okay. And in here we talk more about perimeter, circles, or circumference, pi, arc length. I did not put anything about arc length in your test, but just FYI. Okay. So yeah, so I always tell my students, bring the foldable because we can add stuff to there, and at least you have it organized all in one place. So what I'm going to give you right now for you to write, okay, you should be able to also write it in the foldable, and that way you have it all in one place. Oh, and these little things, this is hamburger patty papers that I bought in Dollar Tree. You're going to need some of this, or any parchment paper would do. But these are really convenient seeds because you are going to be able to use, especially now that we have rotation, reflection, translations in the next chapter. These are really handy. Okay. Okay, there we go. Let's start here. And then again, this being recorded, so you can always go back to the recording and write them down because I do need to move a little fast if I want to cover everything construction wise. So first you need to write down all the theorems that you can use to prove that two triangles are congruent. Now, these are this is how you need to think. What is the minimum information that you need about two triangles to prove them that they're congruent? Okay. And maybe before we start this, I should tell you congruency. Let's start with the definition. What about that? Let's start with that. So we're going to say that two triangles are congruent if all corresponding sides and angles are congruent. Okay. And we have an abbreviation for that. We call it CPCTC. Corresponding parts of congruent triangles are congruent. So it's like the first letter of the big words, not the little words. Okay. So CPCTC. So when they tell you that two triangles are congruent and you want to say that these two sides are equal, this is your justification, CPCTC. So, like I said, you go from congruent triangles to corresponding parts. So here, and then the other thing that you also need to notice is that the vertices, when you're naming segments or naming angles, the corresponding vertices need to match. So if you're saying that A corresponds to D, anywhere where you write segments of angles, A need to correspond to D. If you're saying that B corresponds to E, anywhere where you write it, B needs to go with E. And if you're saying that C corresponds to F, anything that you write needs to say C goes to F. So you see us here, we're saying that AC, this side, right? We're saying that this side corresponds to this side. And we're saying that AB corresponds to DE. And then we're saying that BC corresponds to EF. And remember that they don't have to give you the number, like this measures 5, 6, 7. No, they don't have to give you the number. They can also give you these little tags. So this little tag, see, matches correspondingly to that little tag. These two little tags match it correspondingly to those two little tags. And these three little tags match it correspondingly to these three little tags. Okay. And I know this is tiny, and this is what it says down here. It says always write the corresponding vertices for congruent triangles. And that goes not only for triangles, that goes for any congruent polygons, right? If you're saying that these two are congruent, that means that all the matching sides, all the matching vertices, and all the matching angles are congruent, right? They measure the same. So CPCTC. So you don't be afraid what the heck that is. This is what this is, okay? Now let me go back to the what you see earlier. Nope, that's not it. This one. Okay. So again, we're looking for the minimum amount of information to prove that the triangles are congruent. So I don't know they're congruent. I need to prove it. Okay. So what is one of the minimum information that you need? All three sides. Even if they don't give me the angles, even if I don't know the angles, the measurement of the angles, but if they give me the measurement of the sides, I already know that the two triangles are congruent. And I just need to match the congruent vertices. So as you see here, AB matches with FG. AC matches with FE. And BC matches with EG. Okay. So, or G, sorry, BC is G. So you see that you're matching corresponding sides. So if they give you all the corresponding sides, then you're going to say that the triangles are congruent by side of triangle congruency. And it's important that you write triangle congruency because we do have a side of triangle similarity. Okay. So when you're justifying, you want to say that is triangle congruency in this case. Okay. Then you have, that's the first one. Then the second one is side angle side of triangle congruency. And what does side angle side of triangle congruency tells you? It says that if they give you two sides and the included angle, see the included angle? So I'm giving you two sides and the included angle of a triangle, and they're correspondingly the same for another triangle, then that means that the triangles are congruent. So they don't have to give you all the sides. They don't have to give you all the angles. They only need to give you one angle that is included. See, in between, included, that's what I mean. In between the two given sides, okay? So that's where it's saying that angle B is congruent to angle F, that AB is congruent to EF, and that BC is congruent to FG. So we have a side, an angle, and a side. So then we're going to say that the triangles are congruent by side angle side of triangle congruency. Again, you can take a picture and then write it down because, again, these are the justifications that you are going to use on your homework, on your tests, on the class activities to be able to do your proofs. Okay. Okay. So that's the second one. Congruency has 5. Similarity only has 3, but congruency has 5. And also, you have a side angle side of similarity. So always write of triangle. This means triangle congruency. I just abbreviate. Okay. Then you have angle side angle. So now they're giving you two angles in the included side of two different triangles. And you can correspondingly match them, right? So we're matching angle A to angle E, side AB with side EF, and angle B with angle F. See, we listed right here. And you see the side is included. It's important that you say included, okay? The side is included between the two corresponding congruent angles. Then you're going to say that the triangle ABC is congruent to EFG by angle side angle of triangle congruency. Okay, that's 3. 4, it looks similar, but it's not the same because as you see in here, the side is included. In the next one, the side is not included, and it's called angle side because you're going to have 2 angles in a non-included side, okay, of the triangle. Then you can conclude that the triangles are congruent by angle side of triangle congruency. So you see, you're saying an angle A is congruent to angle E, angle B is congruent to angle F, and side AC is congruent to sides EF. And you guys say, Ms. Escobar, how do you know if there's no numbers? Because they don't have to give you numbers. If they use these little tags imply congruency, okay? Or this little curve on the angles, that implies congruency. And as you see, since there are 2 different angles, there's 2 different notations, right? One with 1 curve and one with 2 curves, see? 1 curve and 2 curves. So they don't have to give you the measurement. They can do it this way, okay? They can do it this way, and then you can assume those are congruent. Okay, so we proved that the triangles ABC congruent to triangle EFG by angle side. So these first 4, because there's one more, but these first 4 theorems can be used for any type of triangle. They don't have to be isosceles or equilateral or right. They can use it for any type of triangle. Okay. Now the next one can only be used for right triangles, because we talk about hypotenuse and leg. Just FYI, as an informal definition, hypotenuse is always the longest side of the triangle, and it's always opposite of the right angle. See, I have a right angle, so it's opposite. This is the hypotenuse right here, okay? So they say, if they give you the hypotenuse of 2 triangles being congruent, 2 right triangles being congruent, hypotenuse and leg of a right triangle congruent, to another hypotenuse and leg of another triangle, then the triangles are congruent. So they give you the hypotenuse and then they give you a leg. All right. So that's why I'm saying that AC is congruent to EG and that BC is congruent to FG. Then you can say that the triangles are congruent by hypotenuse leg. And then, yes, we prove that the triangles are right triangles. Why? Because they give us you can also mention that angle B is 90 degrees and the measurement of angle F is also 90 degrees. And that triangle ABC and triangle EFG are right triangles. So we prove that because I have the 90-degree angles. Then we can say that the triangles are congruent by hypotenuse leg. Okay. So we have those 5 that we are going to use along with the parallel lines. I don't remember if I showed it to you or not last class, but I will do it in a moment. Okay, once we finish writing all this stuff. Okay, so then the next one is similar triangles. Okay, so let me give you first. I don't know if this all fits in one page, but let me make it a little wider. Okay, so this is the definition, and I know it's like in a light blue, so let me read it to you. So this says up here, this is a definition of similar triangles. 2 triangles are similar if the corresponding sides have the same ratio and the corresponding angles are congruent. So, see right here? That's 60, this is 60, that's 80, that's 80, this is 40, this is 40, that's 4, that's 8, that's 8, that's 16, this is 5, that's 10. This is the little similar sign. This means similar. See, and I'm labeling all the angles that are congruent, and I'm going to label the corresponding sides. I decided to do small over big, but it doesn't matter if you do big over small. So DE is from my small triangle, and that side corresponds to AB. EF is from my small triangle, and that corresponds to BC. And DF is from my small triangle, and that corresponds to AC. And then, of course, 4 is not equal to 8 or equal to 5 or 8 equals to 16 or 10. But if we simplify each corresponding side's ratios, we are going to end with the same ratio, which is 1/2. So all the corresponding sides have the same ratio, and all the corresponding angles are congruent, right? So that is what it means being similar triangles. So here they gave us everything. They gave you all the angles and they gave you all the sides, right? That we don't need that. Okay. We can have other 3 theorems that can give you the minimum number of information that you need to conclude that the triangles are similar. And that's what we're going to see now. Okay. So the first one is side of triangle similarity. See, I told you that we're the same labeling. That's why you have to put triangle similarity or triangle congruency. Now the side, this side, it says if the corresponding sides of 2 triangles are proportional, then the triangles are similar. So again, so here I have that AC corresponds to DF, that AB corresponds to DE, and that BC corresponds to DEF. And then I wrote the ratios from the sides of the triangle. And once I reduce it, they all reduce to 1/3. So that means that these triangles are similar, not congruent, similar. See the little notation? Similar. By side of triangle similarity. So see, I don't know anything about the angles because they did not have to give it to me if they give me all the sides. So giving you all the sides is one of the shortcuts, okay? I know I'm going fast, but we need to move fast because it's a lot of information. Then we have angle side of triangle similarity. Again, they are, I know it's kind of like a glare right there, but it says if corresponding sides of 2 triangles are proportional and the included angles are congruent, then the triangles are similar. So here you have triangle ABC, which is a small one, has a side of 20, a side of 30, and an angle of 95 on B. And then we have the big triangle DEF, has a side of 25, a side of 37.5, and an included angle of 95, just like this one. So we know that the angles are congruent. And then we're going to do the ratio of AB is corresponding to DE, and then BC correspond to EF. And then we're going to do the ratios 20 over 25 and 30 over 37.5. Not always you're going to get a nice fraction, especially when you have decimals. But if you divide it, you get the same answer, 0.8, 0.8. So it does have the same ratio. Okay. So since you have the same ratio for the 2 sides and the included angles are congruent, then you can say that the triangles are similar by side of triangle similarity. And then the last one for similarity is the angle. We don't have that one in congruency. We just have it in similarity. So the theorem says if 2 angles of one triangle are congruent respectively to 2 angles of a second triangle, then the triangles are similar. So here you go. Now I draw in here right triangles, so they don't have to be right triangles. It can be anything as long as they give you 2 angles. Here I give you an angle by giving you the 90, and here I give you another angle by telling you that that's 30. So with those 2 angles correspondingly congruent, then the triangles are similar by angle of triangle similarity. I know, take pictures or later on watch the video and you can pause and write it down. So now what's next? Next, which you should have seen in the previous chapter, but I want you to just have it all into one page. So go ahead and draw this and make sure you have the names of the angles in the same position as I do so you don't get confused, okay? So when they give you 2 parallel lines, and remember the parallel lines, they can tell you they're parallel. Okay, they can do this little arrow thingies. This means that these 2 lines are parallel. So here I'm giving you the line 1 and line 2 are parallel. That's a symbol for parallel lines. And they're cut by a transversal T. And as you see, 8 angles are formed, right? So in a label like 1, 2, 3, 4, 5, 6, 7, 8, going around the clock. And you're going to see that several angles, different angles are formed, okay? So you have vertical angles. Vertical angles are opposite to the vertex. See, 1 and 3, they're vertical angles. 2 and 4 are vertical angles. 5 and 7 and 6 and 8, right? And what do we need to know about vertical angles? They're congruent. This is going to help you find those missing angles in those problems that you have in your homework and on your test. Then we have some special angles. Let's see what are the special angles. We got corresponding angle. Corresponding angles means think of these parallel lines as street in your community. Parallel streets. This house is in the top right corner of street L1. And this house is also on the top right corner, but a street 2. They correspond to the same position, but in different streets. So I want you to remember it that way, right? So correspond to the same position, but in different streets. See, 2 and 5, 2 and 6. And what is important about corresponding angles? They're congruent. Okay. So what else is corresponding? 3 and 7, bottom right, bottom right. 5 and 1, top left, bottom left, 4 and 8. See, those are corresponding. And then you have alternate, we have interior angles. So this is the inside, is interior, and this is the outside, these are exterior. So think of a sandwich, right? This is the bread of the sandwich. You have the meat in here, and then I don't know, maybe you put some butter to put in the grill, right? So it's the outside. Okay, so what do we know? We know that alternate interiors, that means that they alternate position from the transversal, and if one of them is in the top right, then the other one is going to be on the bottom left. See, 3 and 5 are alternate interiors. 4 and 6 are alternate interiors. And what do we need to know? They're congruent. Then we have alternate exteriors. 2 and 8, top right, bottom left. 1 and 4, top left, bottom right, are alternate exteriors, and they're also congruent. What else do you need to know? Consecutive angles that goes one to the other, and this one are in the interior. Consecutive angles like 3 and 6 and 4 and 5 are supplementary. That means that they add up to 180. Okay. And then what are supplementary angles? You have a bunch of supplementary angles. Anything that forms a straight angle. See? 1 and 2 form a straight angle. 2 and 3 forms a straight angle. 3 and 4 forms a straight angle. 1 and 4 forms a straight angle. And this is just in this line. We got the same thing down here. So let me write it down. See, right here. See, 1 plus 2 is 180. 1 plus 4 is 180. 5 plus 8 is 180. 2 plus 3 is 180. 3 plus 4 is 180. 7 plus 8 is 180. 5 plus 6 is 180. And 6 plus 7 is 180. So anything, and that's what it says right here. I know it's messing. It says add up to 180 and forms a straight angle. I'm sorry that I used this pen and it didn't work very well. Again, you are going to be using this as justification for that activity at the very end, which you do have also in your workbook, okay? And I'm talking about pages 106, 107, and then the application problems of 108 and 109 and 110. Because you do have, very similar to those you have in your homework and in your test, okay? But you have to justify. So let me show you quickly, right? And I tried to go from easy to hard, right? So I first did, let's see, page 7. This is from the previous section, right? So these are from the previous section. Let me just move on from here. Which again, but if you want it, that's fine. So this is like one of the problems on page 79. So I divided the figure into 2 according to the transversal, because these are my parallels and that's the transversal. These are my parallel and that's the other transversal. And then when they say justify, this is what it means. You need to justify. See? Justify, justify, justify. Corresponding angle congruent, same side interior supplementary. Corresponding angles congruent, alternate exteriors congruent, alternate interiors congruent. See? So you need to justify vertical angles congruent. Same side interiors added to 180. So you needed to be able to justify in your homework. And okay, let me see this one. This one is like number 1. So for example, this is number 1. I gave you an example right here, right? But this is this one, number 1. Okay. So that one says the first step that you need to do, and I know you have more information in here than what originally came with. The first thing you need to do in your proof statement is to write everything that they're giving you. What are they giving me? They're saying that AB is perpendicular to ED, and the B is the midpoint of ED. Okay. So that is given. What's next? Well, the next thing, what does it mean midpoint? Means that it cuts in half. So that means that DB or BD is congruent to EB. See, that's why I put those little lines, because they're congruent. And I also tried to separate the 2 triangles so you guys can see what information I have. So I got that. Then I need to write that those are right angles, because it's important. How do I know that? By definition of perpendicular. I'm going to have that angle ABD and the measurement of ABE are 90 degrees by definition of perpendicular. Then this is one that you don't have. But when you see right here, what does these 2 triangles have in common? BA or AB, right? It's exactly the same segment. Exactly the same segment because they're sharing it, right? It's exactly the same segment. So when you have to reinforce, and yes, you do have to do it, when you have to reaffirm that something is congruent with itself, that being a segment or an angle, you're going to say that that is the reflexive property. When something is congruent with itself. Reflexive property. So now I'm going to come back here and see what do I have once I reach this point. I got side, side, I got angle, angle, and I got side, side. So I can come down here. It says that these two triangles are congruent by side, angle, side of triangle congruency. You see, you develop the statements and the justification until you reach what you wanted. And that's what I wanted. Does that make sense? So that's exactly what you have to do. Let me see, where did I put the homework? Okay. So you see right here in these, you need to explain how the triangle, if the triangles are congruent or not, and why. And when you see that I just left a blank, you need to, if let's say you write for this one, you write ABC, you need to make sure that you match the vertices of A first with one of these, of B second, and of C third. You need to match them. If they don't match, you're going to get it wrong. That's first. The second part is to explain why or why not. So if you're going to say the triangles, you're going to say are congruent by, I don't know, angle, angle, side. Okay. Of triangle congruency. Or the triangles are not congruent. Okay. Because they don't give me enough information to determine the congruency. Whatever it is. Now remember that I may not give you all the information. So let me give you a hint. You see here how in this one I gave you 60 and 65, but I did not give you that one. And you know how in this one I give you 65 and 55, but I don't give you this one. What do you know about the sum of the interior angles of a triangle? They need to add up to what? 180, right? So we did all that in the previous section. It needs to add up to 180, right? So you can find easily, because I give you two of the angles, you can find easily the missing angle. You can find easily the missing angle. And then you can say, okay, do I have enough information to conclude that if the triangles are congruent? Remember that we don't have an angle, angle, angle on congruency, okay? So just FYI. The same thing for 4, but this is for similarities. They also need to match vertex with vertex, and then you need to tell me if they're similar or not and why, right? Remember we have 3 for similarity. Angle, angle, or we have side, angle, side, or side, side, side. Those are the 3 that we have in triangle similarity. So again, you need to label it and tell me if you have it. And then on this one, I'm telling you that the triangles are congruent. You don't have to prove it. The only thing I'm measuring to see if you understand here is if you know what are the corresponding sides, if you know how to write it, if you know what vertex matches with A and what vertex matches with B in this triangle. That's all I'm saying. So if you write it backwards, you get it wrong. So make sure that you're labeling the matching sides vertex by vertex, okay? And then 6, I'm going to address in a minute, and 7 too, because those are constructions. And then we're going to see here they're saying that the triangles are similar. So these are very similar to the problems that we're going to see in a minute, okay? And actually you have one that is very similar to B in a minute, but this is the proof. See right here? This is one of the proofs, okay? Just like the ones that we are doing right now. And this is to prove that that this triangle is isosceles. So let me give you a hint for this, okay? And it says, Ms. Escobar, but we only been proving if the triangles are similar or congruent. Correct. So read what they give you. They tell you that AC, which is already marked, is congruent to AD. They're giving you that angle E, where's E? EDA, this angle, is 110. And that BCA is also 110. And that this angle is congruent to that angle, right? This is right here. So what do you see? You see that this little triangle ABC is congruent with this little triangle ADE by what? By angle, side, angle, angle, side, angle. So you're proving that these two smaller triangles are congruent. Okay, so that's why when you're writing the justification here, that is what you need to find. If you can prove that these two triangles are congruent, and I just told you this, right? So, but you need to list the corresponding angles, the corresponding sides, and the other two angles. They're congruent. So you're going to say that these two triangles are congruent, right? So we need to do the triangle ACB is congruent to triangle ADE by angle, side, angle of triangle congruency. And you can say, Ms. Escobar, so what? Well, since you prove that they are congruent and these two sides are the same, then you're saying that the triangle, that AB, right, that this side right here, that side AB is going to be congruent to this side AE, right? So that's what you need to reach. You need to reach that AB is congruent to AE. This is what you need to prove. And then we just prove it because the triangles are congruent. So why are they congruent? By CP, congruence parts of congruent triangles are congruent. By CP, these two sides are going to be congruent because the triangles are congruent. Then you can say that by definition of a isosceles triangle, triangle ABE is a isosceles triangle. But you see how you have to use all these little tiny pieces of information that we have collected so you're able to reach what you want. Okay, so yes, so that's why you need to have it. That's what I always ask the students to create a foldable because they can write everything in one place and then refer to it when they need it. Okay, and then these right here, you just need to say, according to the information, I'm a visual person. So even though I don't say draw it, right, for A and B, part A and B, I don't say draw it, but it helps if you draw it because it helps see it. Okay, so for A and B of part 10 of part A and B of 10, and then again on C, basically you just need to see what is the information that you need. So what is each one giving you to determine if they're two equilateral triangles. Remember, equilateral means all the sides are equal. And on this one, again, you want to see if they give you enough information, and I kind of answered this earlier, enough information to determine if the triangles are congruent. Okay, so let me show you the other part that you also need to know, which is the constructions. Okay, and I know, just bear with me, please. I'm sorry. Okay, so let me show you these other ones. I'm going to show you one for congruency, one of the problems for congruency before we go into the constructions. So see, this is an application problem that is for congruency. So you have this distance is what you need to find, and they give you these two distances and these two distances and that distance. So you don't know what this is because you don't know if the triangles are congruent or not. So the first step that you need to do here is to prove that the triangles are congruent. And then I list everything that they gave me. I know that XC is congruent to XR because they have the same measurements. And XB is congruent, let's see right here. XB is congruent to XY because they have the same measurements, right? You can say given because they have the same measurement, right? And they also gave me that YC is 34 meters. Now, what else is not given, but we can find out? We can find out that these two are congruent. Why? Because they're vertical angles. You see how that information from the past chapter comes into here? Because they're vertical angles. And now what do I have? I have a side, an angle, and another side. A side, an angle, and another side. So I can conclude that these two triangles are congruent by side, angle, side, or triangle congruency. Now we're going to work like we work on that one that you have in your homework. So now what do I know? Since these two triangles are congruent, that means that YC is congruent to RB. And I know that YC is 34 meters. So by CPCTC, corresponding parts of congruent triangles are congruent. That means our RB is also 34 meters. So you see, it's not just as simple. You do need to be able to create kind of a proof and then be able to determine your answer. Make sense or no? So let me show you I'm going to show you quickly one with similarity. Right, this is 3, and this is for similar triangles. So we have the person, the runner, and then we have not the runner, and then we have the climbing wall. We have the shadow, and yes, we are going to assume this is not the towers of Pisa. So we assume that all constructions are perpendicular to the ground. Otherwise, they will move, right? They will fall. So we are going to assume that we have 90-degree angles because they're perpendicular to the ground. So we know this is 90. We know that this angle of inclination because of the sun is going to be exactly the same. So we know that that angle is the same. Okay. And then we have the corresponding shadows. So we know that these two triangles are going to be similar because of angle. Okay, we know they're similar. So what do we need now? We need to find if the ratio, because we're missing the height of the wall. We need to find what is the ratio, the common ratio. So they give me the real height of the woman, but it did not give me the real height of the wall. And then they give me the shadow for both. So I'm writing real over shadow, real over shadow. So this is of the woman, and this is of the wall. See, real height, I don't know. This is the shadow. This is real height, and this is the shadow. So now what do you create? You created a proportion. So we just need to pass this multiplying over here, see? And you get the final answer, which is 460.6 centimeters is the real height of the wall, okay? And I am going to show you also, if you want to take a picture of the other ones that you needed to work on. This is the other congruent one, 109. This is problem number 2. And then the other one, which is the other similarity one, right? And see here, we use the parallel lines corresponding angles. So this angle is congruent to that angle because they're corresponding angles. And they both triangles share that common angle. So this is like reflective, right? Reflexive with itself because this is angle A is congruent to angle A. So the two triangles are similar. So that means that the whole length, and this is careful, is 45 miles from B to C and X miles from A to B. So when you're finding the big triangle side is X plus 45. See, that's AC. And the small triangle side, AB, is X. And then the small triangle, this side is 70. And the big triangle side is 90. And then we do the same thing. We cross multiply, in this case, both of them. Don't forget to do the distributive property here. And then we're going to group both the x's on one side and divide by 20. And you get it is 157.5 miles. It's just X. It's AB, which is what we were looking for. And then let me give you the proofs. The other proofs, because I show you the first one, but I did not show you the second one, the fourth one, third one, or fourth one. So this is the proof for 2. See, very similar to that other activity, the one that was with the problems that we needed to find this side. See, very similar. So these are the proofs. Then you have this other one, 3. That's to prove similarity. By angle, they tell you that that's right, and these are vertical angles. So by angle, they're similar. And then the last one up here, right? So this one, they tell you that this is 2/3 and that's 2/3 and that's 9 and this is 9, right? So very similar to the application problem, right? We're also going to think of the angle B as reflexive with itself because they share that. So then you have side, angle, side of triangle similarity. Because if you reduce it, it's 2/3 of reduction, right? 6 over 9 is 2/3. So 2/3 is the ratio. So obviously they're similar. Okay, and then for number 1 on the homework, I want to see you write water congruent triangles. And I want you to write water similar triangles. And I gave you both definitions today, right? That's one of the first things you wrote down. Both definitions today, okay? And then if you remember from 1350, we use base 10 blocks to add and multiply whole numbers, right? We use pattern blocks and Cuisenaire rods when we were doing fractions. And what do we have in this chapter? In this chapter, we got geoboards that we use to form, if I can find it. See, we had geoboards to prove, to form different triangles. That should be able to help you answer that first question, that second question in there, right? And then you can also use, you don't have to use string and paper and stuff. You can use GeoGebra. GeoGebra, and they have like a specific thing that you can use to be able to draw different triangles and being able to close them, see? And we use the triangle inequality. Remember we did that last class? We have that, and then we have, if you're interested, the different triangles that you can form. So you can combine sides with angles. See, this is a right isosceles triangle. Okay. Yeah, and then quickly the constructions, because that's what you have on 6 and on 6. So I'm going to tell you something about 6. 6, exactly 6, is on page 95. See, I give you the steps, 95, 96. So you can just order them. You have all the steps right there. And the same process that we do here, which, and so the metal ones are the best ones. Plastic ones, sometimes they're not sturdy enough. But basically, if you follow the rules, the first thing you want to do is create a endpoints, because that helps you anchor your little pointy part. Okay, and then it says you want to create a curve. Okay, you want to create a curve, and then the same width that you created the curve, the arc on that side, you're going to flip it over and create another curve on this side. And you're going to see that the curves intersect on the top and on the bottom. So on those points right there, you're going to make it darker, and then you're going to use a straight edge, and you're going to draw the perpendicular bisector. Right? So, and that's why you get in that. Let me see right here. Let me find what you need to write in there. So that's what we get, that AM, because I call that point M, where they intersect the segment AB, that AM is congruent to BM, because again, perpendicular means that they form 90-degree actors, but bisector means that they cut it in half. So they cut in half the segment in point M through the perpendicular bisector. The lines are perpendicular, that means that they form 90-degree angles. Okay, so again, and then one of the things I ask you, what would you notice? So any point, and this is something you can write, any point that lies in the perpendicular bisector, any point here or here or here, it doesn't matter, that you draw the segments from the perpendicular bisector to the endpoints of the segment, they're going to be equidistant. Okay, the segments are going to be equidistant, and it doesn't matter. Now these two are going to be different, obviously, if you draw it from here, right? This has a different size than that, but these two are congruent because they're going from the same point on the perpendicular bisector to the endpoints of the segment. And then you're going to have the same thing done for if they give you a point on the line, the first thing you're going to do is construct the segment, because you cannot do the perpendicular bisector unless you have the segment. Construct the segment, and then you're going to do the arcs only on the top. You don't have to do it on the bottom. And then you're going to connect that point with the one that you had on the line. And then you're going to do the same thing with the points outside, right? With the point outside of the line. You're also going to create from that point, you're going to create the curves. So you can create the segment. And once you have the segment, then you just need to create another arc down here and connect those 2 points. Just follow the steps in here, okay? And then the last one in here, that it was the parallel lines. See, we're using corresponding angles. You see right here? Corresponding angles, that's how we created this one. We created corresponding angles, so we were able to create parallel lines. So a pair of corresponding angles are going to be parallel. And then the other one that you have in your homework that you literally have to write the steps, right, and draw it, is on page 97 and 98. See, on page 97 and 98, you need to construct the perpendicular bisector. So try to summarize as much as possible. I did not put here labels. So since you're copying this, put the labels, put the same labels since you're copying step by step in here, okay? Put your labels. And then basically for that one, that is even easier. You are just going to put your pointy part. Again, the workbook doesn't put good periods in there. So you are going to basically do you can do an arc if you want. So just do an arc that crosses both sides. And then you're going to use from those little points, you're going to do an arc up here, and then don't change it and do an arc up here. So we use the same length, see? We use the same length for all of it. And then once you have it, that little point and the vertex of the angle, you just draw it through there. And that's your angle bisector. Of course, I sucked at drawing this thing, but that's your angle bisector. And then what you need to conclude in that one, let me show you the conclusion. This is the conclusion. We said that angle ACM, which is this little piece that I actually measure with a protractor. You don't have to measure with a protractor. That angle ACM is congruent to angle BCM. Okay. And that the ray, because this is a ray, not a line, ray CM is the angle bisector of angle ACB. So that's what you need to write in that one. Okay, guys. Okay, so in the project, see right here, the website doesn't let you label. So this is what I do. We need to have it matching exactly this design right here. So I am going to, let me see if I can have two side by side. Let's see. Would it show both of them? Let me see. No, it doesn't show both. Okay, so let me bring it back. Okay. Come on. Okay, so what I do is that I do a snippet. You know how you have snippet on your computer? So let me do here snippets. I have a snipping tool, and then I use a snipping tool. But before you do the snippet, you want to select the whole thing and turn it, because again, it needs to look like this one. See how you have AB, and then the parallelogram is over here, and the small triangle and the medium triangle? So this is how you want. Then once you have it like this, then you're going to do the snipping tool. Where did it go? Okay. New. And you're going to copy it. And then let me show you snipping tool. In the snipping tool, you're able to label. See right here, you have the little things to label. And then we can know that this is A and that's B. And I forgot already all the other ones. I think this was C. I don't have it right now. But so you see that you label. So you use the labeling of the snipping tool. And then you take the picture, right? You say right here, it says copy. So once you're done labeling, you copy it and then you paste it on the Word document. Okay. And that's what you're going to do. Let me go ahead and close that one and then do a new one. For the project, Tangram, yes. See right here, and it says, can you make a square with 2 pieces? So you need to come here and use 2 pieces. See right here? And remember, we already have it labeled. So this is A and this is B. And if you don't have it labeled, that's fine. You can label it now. Take a snippet and label it A and B. And then you go and plot it over there. Okay. And then you do the same thing. See the tiny ones? You can also do the tiny ones. See, I'm giving you the answer for the second one. See? And then whatever these letters are, these are what? D and F, right? These are D and F. So you have the different with two. And then you're going to do the same thing if you have 3. And there's always, they're all possible. Let's start with that. They're all possible. And some of them may have more than one option. I hope that makes sense, right? So they have more than one option. And then this activity, all 5 problems answered, it worth 25 points. The second one is the same thing. You need to have several meaning at least 5. Okay, you need to have 5 polygons drawn. Do you want to use the same ones right here? You can. Okay, so and when you're using all 7 pieces, not just 2. All of the 7 pieces. All of these pictures right here, I done with all 7 pieces. You do have a boat. It is not this boat. Okay, so make sure that you understand that this is just to help you use the Tangram and don't have to cut out. That's what my students used to do in the past. I used to give them to them to cut out. I don't know if somebody is like doing enter because it's not supposed to be down here. I don't know why it's changed all the things. Let me see. Maybe I can do the PDF. There we go. This is much better. Right. So in here you have the space. You need to do several. And you can use those. You can do the same thing here. You need to have 5, at least 5 different ones. 5 convex polygons. Okay. You need to draw them in here. And then again, you're going to use the Tangram pieces, all of them, to form these. And then some students, they just like draw on top of this, or they actually form it here and take a picture and plot it in the Word document. You can do that too. And then the last activity, you remember how we had A, B, C, D right here? Well, sorry, we had 2 pieces, 3 pieces, 4 pieces, 5 pieces, right? We over here, first we're going to calculate the area for each one of these. See, A and B, they have 1, 2, 2 halves make 3, and another 2 halves make 4. So these big triangles are 4 unit squares each, okay? So that's how you count it. So once you do that, so for example, what we did with 2 pieces, you're going to put, again, the same drawings you had at the beginning. You put it again here, and then you're going to put the area for each one. The same ones that you had with the lettering, A and B, right? That's the big square. And the big square is going to be what? 8 unit squares, because this is 4 and this is 4. So you do need to answer. And if you have any, for example, I think 4 pieces has several. You need to show me all the ones that are possible. And then the area for each one of those, okay? And the same thing with 3 and 5, okay? So each part is worth 25 points, each part, for a total of 100 points. So if you're missing any parts, again, if this has 5, and it's worth 25, that means each question is worth 5 points. Does that make sense? So same story, 5 designs, 5 points each, right? And here I think I changed the value for each one. I think it's in the rubric. But anyway, so okay, now for sure. Now I'm done. I just wanted to answer any